My name is Carly McFarland and I'm in Section Lab 9. And this is the video lab report for experiment number 2, reactions of copper and percent yield. This table will be a guide to use when identifying the compound to fit the description of the physical property. In the first step of the experiment, copper turnings were combined with nitric acid. This resulted in forming a compound called copper 2 nitrate. The description taken from the experiment included a brownish red gas, it turned a color green, it heated up, and it ended in a bright blue state. So according to table 2.1, those descriptions match up with copper 2 nitrate. This reaction resulted in a gas being omitted, which is described as NO2. The gas that was omitted was NO2, which is described as a brownish red gas on table 2.1. The next step involved adding sodium hydroxide to the copper 2 nitrate. Adding the sodium hydroxide to the copper 2 nitrate resulted in copper 2 hydroxide. The description of this reaction turned the solution a dark blue color. It had a cloudy precipitate in it, and it was a jelly-like composition when this capillary tube went into it. The table describes that as copper 2 hydroxide. This also let off a gas which is known as sodium nitrate. Next in the experiment, heat was added to the copper 2 hydroxide. This resulted in forming a solid called copper oxide. Along with the solid that was in the mixture, it was followed by H2O. When the copper 2 hydroxide was heated, black chunks formed, the liquid became clear, there was a clear separation in solid and liquid, and the solid looked dirt-like. On table 2.1, it shows that this is copper oxide. Next in the experiment, sulfuric acid was added to the copper 2 oxide. This resulted in forming copper sulfate. When sulfuric acid is added with copper oxide, it produces water as well. The next step in this experiment is adding zinc to the copper sulfate in water. This produces hydrogen gas, and it also produces zinc sulfate. During the reaction, the copper sulfate and zinc had bubbles, it warmed up, and at the bottom it formed a red-brown solid. The aqueous solution that the copper was in was defined as zinc sulfate, which makes it a colorless solution. There was also a gas omitted, which was colorless, meaning it was hydrogen. It also produces solid copper. And that takes us back to the beginning. The solid that was formed at the bottom was copper, which is described as a shiny solid or reddish-brown powder. The data that was obtained from the experiment is shown on this chart. The initial mass of the copper was 0.504 grams. The mass of evaporating dish was 37.152 grams. The mass of the evaporating dish and recovered copper after the experiment was 37.476 grams. To find the mass of the recovered copper, the mass of the evaporating dish has to be subtracted from the mass of the evaporating dish and recovered copper. Percent yield is described as the recovered mass of a sample divided by the initial mass of a sample multiplied by 100. To find the percent yield, 0.324 grams is divided by 0.504 grams. Then the number is multiplied by 100. After doing those calculations, the number received is the percent yield of the experiment. These calculations conclude that the percent yield of this experiment was 64.3%. Theoretically, the percent yield should be 100%. However, there are errors that can take place that can cause the percent yield to be greater or lower than 100%. If the percent yield was greater than 100%, it could mean that the sample was not fully dried when the mass was taken at the end of the experiment. If the sample was not fully dried and there was still water left, the sample amount would be greater than what you started with, causing the percent yield to be greater than 100%. If the percent yield was less than 100%, there could be multiple different errors that resulted in that. But one of the errors is that during the experiment when precipitates formed, they were not fully captured by the experimenter because they got caught on either the sides of the glass or the stirring rod. This would not be the fault of the experimenter because some of the precipitates just ended up sticking to the sides of the glass or the stirring rod. If the precipitates were not fully captured, then the mass would be less than what the experimenter started with, resulting in the percent yield to be less than 100%. This table is from the Chemistry 110 Foundations of Chemistry Laboratory Manual. Instructors Dr. Booth, Dr. Jean, Ms. Santoro, Mrs. Salutis, and Ms. Schaub.